today I'm going to cover the question search in rotated sorted array. So if you so this array is originally sorted in ascending order. Now at a given pivot index that which can be any random index between 0 and length, that index is essentially rotated to now have the new index value as 0, and essentially there is a rightmost value which is any value, random value between the minimum and the maximum, and the minimum and maximum are adjacent to each other now. So in this situation, after possible rotation, there is a target integer. We have to return the index of that integer to find it, and we have to solve this in logarithm time. So the first intuition is that this should be done in binary search format, such that we are able to like in every step we are able to slice the array into one half or the other. And so one very useful information over here is the rightmost value, because that value can always set us can always guide to whether to look in the first half, which is the greater half, or the second half, which is the smaller half. So, and essentially, so we can think about the like how to go about solving this. So let us define left and right to be equal to 0 and length of nums minus 1, and then we can define the rightmost to be nums minus 1. We can see that the numbers length is between 1 and 5000, and the values are unique, so binary search can work in a normal way. And yeah, so essentially we can always define mid. So we can define our binary search as left. So now we can define mid as the floor value between left and right. So now if nums of mid is equal to target, then we can just return mid, right? Now the thing is that if nums of mid is so now the condition that we were describing earlier, that if nums of mid is greater than rightmost, right, then essentially we can say that, so now ideally we should be searching in the for if nums so so the idea is that if target is greater than rightmost, right, so basically we should be searching so if nums of mid, if this guy is greater so because this is the case, it just means that we should search in the first half, right? So if nums of mid is less than rightmost, right, then so essentially we can, or this can be one scenario where this number is, because we want to search in the greater half, but if the current number is less than less than the rightmost, then we definitely need to update uh, right as mid minus 1, right? And the idea is that um, so basically that this is one scenario, and the other scenario is that if nums mid, right, if this guy is essentially basically if this guy is greater than target, right? So essentially what this means is that um, that it is in the first half, which is the greater half, but at the same time this value is actually greater um, than the target value. So let us say this is the end array, and if the target is 5, right, and if we are at 7, in this case also we need to go, if mid is 7 we need to search in the left half, and else we can say that left is mid plus 1. So the only scenario for this would be that if the target is say 6 and we are at 4 or we are at 5, in that this is the only scenario in which we need to search, we need to go search in the right half. So in this case visually what this means is that if we are at 0, 1 or 2, right, so I think this should be less than equal to, so if the target is greater than rightmost, and this is, if this is less than equal to, then we need to search in, so if we are at any of these values we will search in the right half. If we are at any of these values which is greater than the target itself, we will also search for left, right? Now in this case if the idea is that we actually want to search in the first in the second half or the smaller half. So in this case if nums mid is greater than rightmost, right, or nums mid is less than target, in this case we can say left is mid plus 1, else right is mid minus 1. And finally if we are unable to meet these conditions, then we can just say this, we can just return minus 1 if this is not found. So these test cases are passing, and yeah, I just ran this few times, so yeah, this is running fine.